So in this problem, we need to show that the relation R on the Cartesian product of a natural number with itself, and which is defined as the ordered pair A comma B or the ordered pair C comma D, if and only if A plus D equals to B plus C for all ordered pairs A comma B and C comma D belonging to the Cartesian product of natural number with itself as an equivalence relation. Okay, let us begin. So in order to show that the given relation is an equivalence relation, we'll have to show that it is reflexive, it is symmetric, as well as it is a transitive relation on N. Okay, so we'll first check whether it is reflexive or not. So to verify whether if it's reflexive, what we'll do, we are going to consider an arbitrary element, let A comma B be an arbitrary element in the Cartesian product of N with itself, such that if we consider the ordered pair A comma B related to the ordered pair A comma B, then this relation simply gives us that A plus B must be equals to B plus A. Fine. And this is a true statement, which is true, which is indeed true as addition is commutative under N. That means under the set of natural numbers, addition is commutative. This is a true statement. If this is a true statement, that means this must be true. Thus, we can say that A comma B is related to A comma B for all A comma B belonging to the Cartesian product of the natural number with itself. If you are having any doubts how we got A plus B equals to B plus A, let's look at the original relation. It's given here that the ordered pair A comma B is related to the ordered pair C comma D if and only if A plus D equals to B plus C. Now what is A here? A is the first element of the ordered pair A comma B, whereas D is the second element of the ordered pair C comma D. So here we are adding C with D, and then this is equals to the addition of B and C. However, to show that it is reflexive, we need to show that if we consider the element A comma B, which is an arbitrary element in the Cartesian product of N with itself, then we need to show that this relation is true. That means the ordered pair A comma B is related to A comma B. That is what we had to show. And if we use this condition that is given to us, then what we got was we added this A with the first element of the ordered pair A comma B to the second element of the ordered pair A comma B to get A plus B on the left hand side, and then this will be equals to the addition of the remaining two elements. That means the second element of the first ordered pair A comma B and the first element of the ordered pair to the right of R. So that gives us B plus A, and since A plus B equals to B plus A, and we know this is this is true because addition is commutative under N. So we can say that A comma B is indeed related to A comma B for all ordered pairs A comma B belonging to the Cartesian product of N with itself. Okay, so this simply implies, now what does it mean? Hence we can say that the relation R, hence R is reflexive. So we can say that R is reflexive on the ordered pair N Cartesian product with N. Okay, so the first part is done. Now let's go to the second part. That means we will show that our relation is symmetric. So how to check for symmetry? Now in order to verify whether if our relation is symmetric or not, we will be considering two arbitrary elements. So let those elements be A comma B and another element be C comma D, and both of this belongs to the Cartesian product of the set of natural number N with itself. And we're going to consider this such that if we suppose that A comma B is related to C comma D, then this must imply, because by definition this simply means A plus D must be equals to B plus C. Okay, now if A plus D equals to B plus C, can we not rewrite it as B plus C equals to A plus D? Fine. and we can rewrite b plus c as c plus b, whereas a plus d can be rewritten as d plus a. The reason why we're writing this is because if this is true, c plus d equals to d plus a, this simply means that we have c comma d, the ordered pair c comma d is related to the ordered pair a comma b. So we are able to show that if a comma b is related to c comma d, then it implies that c comma d, that's the ordered pair, it is also going to be related to a comma b, and that is the criterion for a relation to be symmetric. So here we can say that for a comma b related to c comma d, we were able to show that the ordered pair c comma d is also related to the ordered pair a comma b. So hence what we can say? So hence we can say that our relation R is symmetric. So this is symmetric. This is a symmetric relation on the Cartesian product of n with itself. Okay. The second part is done. Now we have to show that it is transitive. Okay. So how do we show that our relation R is transitive? So for this, we'll have to again pick up some arbitrary elements. So let's say we pick up the arbitrary elements as the ordered pair a comma b. Next, we consider c comma d, and then we consider one more ordered pair e comma f. And all of these three ordered pairs, let's say they belong to the Cartesian product of n with itself. Okay, such that we are considering that a comma b, this ordered pair is related to the ordered pair c comma d, and we have the second ordered pair c comma d is related to the third ordered pair e comma f. Fine. Now what does it mean when we say that a comma b is related to c comma d? So we have a plus d equals to b plus c. Fine. And c comma d, the ordered pair c comma d related to e comma f, that simply means that c plus f, this must be equals to d plus e. All we're doing is take the first element of the ordered pair c comma d and add it to the second element of the ordered pair e comma f. That will be equals to the sum of the remaining two elements. Okay, d and d. Now a plus d equals to b plus c, but what we can do here, we can isolate, or we can isolate d from here. So that's going to give us b plus c minus a. And what we'll do, we will replace this d back in this position such that we get c plus f. So that will be equals to, so in place of d we have b plus c minus a added to e. Fine. Now what we can do, we can cancel out c from both sides and rewrite the terms to get a plus f. This is going to be equals to b plus e. Now what does it mean when we say a plus f equals b plus e? That means that comma b, this is going to be related to the ordered pair e comma f. Fine. So we started out by considering that a comma b ordered pair is related to c comma d, and also c comma d is related to e comma f, and we were able to show that a comma b is related to e comma f. What does it tell us? This simply tells us that the relation R is also transitive. This is a transitive relation on the Cartesian product of the natural number with itself. Now what we can do, finally we can say thus our relation R is an equivalence relation on the Cartesian product of n with itself. Fine.